Hello and welcome to episode 6 of the Slack Chat podcast, where we're going to be talking about the Slackware Linux distribution and in particular using Slackware on ARM devices. So I'm Stuart Winter, I'm the developer and architect of the ARM port of Slackware, and we've got Phil, who is the maintainer of the SAPI project, which allows you to easily install Slackware ARM onto the Raspberry Pi. And we're going to continue from where we left off at the end of episode 5.
I think the ARM devices are useful for because they're cheap and for ease of swapping SD cards. So you have two SD cards. One's got Slackware on it and the other's got Ubuntu, say. So you want to run these two systems for different reasons, and it's just a case of swapping SD cards. That's one beauty about the devices, the ease of which you can swap systems. And another aspect of it is cost. You're not forking out hundreds of dollars for a system specifically to run Slackware. It's
absolutely.
It's relatively cheap.
Absolutely. I'm really glad you said that, actually, because I was thinking what we would talk about on the next podcast. And I think, with this podcast, what we're really doing, bear in mind what you just said about the price. I think it's really a case of advocating for what is actually an incredibly stable, mature distribution that's been around pretty much since the year dot and has been maintained by the same person. So you've got this consistency of user experience, and you then, as you said, you don't need to buy an expensive piece of Intel hardware, or you don't have to put it into a virtual machine, although that's also that's another very good option. As you just said it yourself, and you reminded me of how ARMSlack started, physically how it started. You just said you were taking out these SD cards and swapping them around. That physical hands-on of swapping the cards around, of oh my god, it hasn't booted, the physical involvement, I think it's also where partly the interest is, partly the passion comes in. It's not just about clicking on this and clicking, it's actually plugging stuff together, which is what you can do with ARM really cheaply.
Yeah.
And, you're not going to break it, but because you could, but you're not going to break it. So, but even if you did, it's really inexpensive just to buy one. And so, so for example, when I started the initial port of ARMSlack, it was a lot of work, and what I was doing was, because there was no such thing as an SD. I don't think there was. There was some kind of compact flash or something, but I didn't have any of that stuff. And I had my RISC PC, my old Acorn RISC PC, with the top permanently off of it, and I had a spare Intel 586 with the top all the guts hanging out of it. And was it? No, it was a Solaris box actually. I was using my Sun desktop. Oh yeah, it was that. That's right. I got that from somewhere. So anyway, loads of different machines, and one of them was like the command center where the terminals are permanently open. The way I had to do it was to try and bootstrap it. It had Slackware x86 on it as the operating system, and it had another disk, another IDE drive, which had what was becoming ARMSlack on it. And so the Debian guys had said, look, the easiest way to get your ARMSlack fast is by using this build system called Scratchbox, which is what some of the Nokia guys had put together to build packages for the Nokia phones. And so that was called, I don't know if it still exists, but it was called Scratchbox. And actually there's two parts to this. The first, that I was cross-compiling it. So I got a cross-compiler tool chain. I think I built one, and I'd also downloaded one, because it was quite difficult to do back then. It's not anymore.
Yeah, I can imagine.
Peter Knowles from the Debian ARM had helped me as well with that. So I got this together. So I cross-compiled Bash, I cross-compiled zlib, and a few other things. However, when I came to building ncurses and some other things, ncurses doesn't build because, well, it did. But what happened was there was a part in ncurses where, and this is what happens with quite a number of packages. They build themselves, and then they decide it's time to go build some data files, or time to go and build some stuff with binaries we've just compiled. Doesn't really work very well when you're trying to run an ARM binary on an x86 where you just cross-compiled it. Yeah. So then curses would say, hey, trying to build whatever it was, the terminal. Oh, I can't remember what they're called now, but basically it has definitions for how terminals look. So I think I'm right on this. If that might not be ncurses, that might be another. But basically, it knows what various different types of terminal emulators look like. What were the character sets? How do you paint stuff on the screen? How do the colors work? So that when you look at it on the screen on that different type of terminal, it actually looks proper. It looks how it's supposed to look. So anyway, ncurses would go and try and build these data files, and it didn't work. So the next trick was to use Scratchbox. On my RISC PC, I'd got Debian installed by hook or by crook, and I'd absolutely bastardized it to death, and it was hanging together by a thread. It barely even booted. I don't know. I think I had a problem installing it or something. Even back then, on Debian on ARM on this RISC PC, it needed some. You had to massage it to get it booted. I wasn't in the mood for that. I just wanted to get it doing what I wanted, which was Debian was running, and I got Scratchbox listening on sockets on the local network, basically as a listener service. And what would happen is, I think there was some client software on the x86. Whenever an ARM binary was detected as being executed, I think this is how it worked. It's been a long, long time. But whenever it detected an ARM binary was being executed on the x86, it piped it across the network into the listener on the Debian ARM RISC PC, and then on the Debian box, it ran the binary, and because there was no QEMU at the time, so you couldn't do any of that stuff. You had to run it on an ARM hardware. So it shipped this binary across, it executed it on there, and I don't know exactly how the data got back to the output got back to, I don't remember, I'd have to look at that, but that's basically how it did. So it was shipping these ARM binaries across to a real ARM system, executing them, and then I was getting the data back onto the file system on the x86, and I'd end up having my packages built. And then what I had to do is, every time I built enough, what I thought was enough packages to get the system to boot, I would have to shut down the x86, shut down the RISC PC, pull out the hard disk out of the x86 box, put it into the RISC PC, pull out the Debian operating system, the Linux Debian operating system, put the RISC PC, put the disk back in again, boot the RISC PC back into what I hoped was going to be ARM Slack. And that took forever because it was constantly turning the machine off, having to wait for the disk to spin down so you don't corrupt them when you yank the cable out. And then, it took so long, and and it took me like maybe 3 or 4 attempts to get ARM Slack to actually boot into even just a bash shell without even booting the operating system proper. But these days it's so much easier. You've got cheap access to cheap ARM hardware. You can get creative with it. You can, on like in the Raspberry Pi and on the Banana Pi and all the others, you've got the set of GPIO pins. You can plug in hardware sensors. You can plug in. I mean, if you're actually using your Raspberry Pis for any kind of like home automation or what are you using them for?
Right. There's the Raspberry Pi 1, 2, 3, and 4, and they're all build machines, and they run constantly. If they're not building SARPy releases, they're doing something else. They're always doing something. And then I have a Raspberry Pi 1 B+, and that is my NTP server. And so every device in the house is set to that system. I'm a bit paranoid about accurate time, so I like all my devices to be in sync. We do on FatDog, we run a lot of things, and it's all logged. So all those logs need to be identifiable by the timestamp, and so all the machines are synchronized for that purpose.
I see.
Yeah. Apart from that, what you were saying about it's got easier. I don't know if anybody find this interesting, but when I took delivery of the Raspberry Pi 4, it uses the micro HDMI cables. Now, I had an HDMI cable I thought was micro, but it wasn't. It was mini. So when it actually arrived, I had no cable to use as a display. And the serial connector was at the bottom of the box somewhere. That was, unless I had a Ouija board and a hunting dog, I wasn't going to find it anytime soon. So I thought, what am I going to do? I want to get Slackware running on the Raspberry Pi 4. I've got no cable for a display. I'm going to have to wait. And then I got this idea. This wild fantasy came into my head. What if I guess, and this is how it went in my head, what if I guess what the configuration should be in order for it to boot successfully? So, okay then, we'll try this. And I downloaded the Raspberry Pi kernel and boot firmware and mashed that in with a previous image from the Raspberry Pi 3.
Right.
And then I booted it with where did I get the kernel from? I think what I did, I used the modules out of Raspbian to get it fired up initially. And once it was fired up, I loaded up the Cypress scripts and made myself a build. But I did all that through the LEDs, the error that the LEDs gave off, and the time it took for the kernel to panic. And that was it. And I hand on my heart, I swear down, that's how I got Slackware ARM on the Raspberry Pi 4. It took some hours, but it took me about a day to achieve, but it was successful. And that's testament to the ease of which Slackware ARM can be used and manipulated for success.
But from what you've said, are you trying to say you did this essentially
headless and blind?
Right,
Yes.
right. That's what I was thinking you were saying. Yeah, okay.
Yeah. If I didn't make that apparent, I did. That's how it went, because I had no means of viewing the display. Sometimes
the kernel would get too large. The amount of memory I'd reserved loading the kernel was insufficient, and it would be, for example, you'd load the kernel and then you'd load the flattened device tree, and it would overwrite the end of the kernel, and then so the kernel would just crash because it was truncated.
I thought that got fixed in like kernel 4.4 or something. I'm probably completely wrong.
There used to be there's two things. Years ago, it was that the kernel was just too big, full stop, and it didn't matter. It was just over a certain size. And then the other is that if the kernel slowly creeps up in size, and you've only allocated a certain address space in RAM and U-boot to load it into, and then the next memory location subsequent to that, where you load the flattened device tree in, basically it means that your kernel, you basically give it a start range. Hey, go and load it from here onwards, and it happens to it gets bigger than you didn't originally provisioned it for. So and then you can corrupt it that way around. But when I would do that, I would have exactly the same thing. It wouldn't boot, and I thought, well, is it just because sometimes it's just because the console the support gets moved into different modules, and I haven't got it loaded, and I didn't know it was happening. And then I do things like, okay, well, let's see. It's kind of like what you did. Is like, let's see if it's just headless, but it's actually requesting an IP. So I do like a tail-F on the system, on my DHCP server. Is it doing a DHCP request? If it is, I can log in and at least I can work with it and bring it back, bring back the head again. And see, there's all sorts of like little tricks, like really hacking, sort of rubber duck kind of tricks that you can do. It's quite funny to see. The best ones are the old school ones are the best, aren't they? Just stick some debug code. Does it get this far? Dump out some comments to some file or on the screen or something like that. Yeah, it's good to see that still goes on. I don't do as much of that anymore, but I used to. That's kind of how I used to do it. But I was thinking at one point I was going to make a baby monitor out of one of my old bits of ARM kit. I thought to myself, I know what I can do. I can plug a webcam into it, and I think I can probably use MPlayer to constantly like pull the data off of the camera. And because I can just plug it in, it's silent and this, and then I thought, well, yeah, I didn't do that. I've got too much to do, but it's something you could do. That it's perfectly doable. And I thought I could put some in my greenhouse to monitor the temperatures and the humidity. I could plug all these different things in, and because you can do these things, right? The actual little bits of hardware, they're really cheap, aren't they? And all of the software, the libraries and things to query that kind of those interfaces and get that data is all pretty much available. There's so many things that you can do, and that's one of the things actually I don't really know what most of the people who use Slackware ARM use it for. I've never really known. I mean, there's only been a few people who've ever actually told me what they use it for. Got no idea. So that'd be quite interesting to hear what people really use it for. I mean, certainly, obviously, some people use it for servers and little, headless gateways. I mean, for sure. I mean, I do the same actually.
I have on occasion used mine for testing. You said servers. Well, I've set up an Apache web server many times just to test something, or a domain web server for whatever you would use it for. It's so quick and convenient, and I think not that Slackware is turning from being a dedicated hands-on OS into the convenience of apt-get or point-and-click world.
Yeah.
But certainly things in the ARM world have got easier, mainly because the hardware is is more user friendly and easier to work with.
Yeah, yeah, that's right. It certainly is. It certainly is, and that's one of the. Yeah, I mean, I mentioned in one of the previous podcasts. That's also the hardware that I have chosen to support, which I've got, I've got connected up as some of the build and test machines. That hardware is now, it's all pretty kind of, you'd say it's industry standard. It's got U-boot, it's got various, it's got eSATA, it's got this and not that. So they're really quite, the machines themselves are actually useful.
Mm-hmm.
You could actually use it as a little desktop or some kind of, you can run a user interface off of it. You can use it as a server. I mean, you can run Apache on it. I have Apache running on mine. I have it running Exim. I have it running Pine. I have it running Screen. I have it running mail filtering, spam filtering. It all runs on my 1 gigabyte of RAM Banana Pi.
Yeah.
Like I think it's dual core All-Winner A20.
Mm.
So that all works, and it's got eSATA as well. So I've got my eSATA drives that's on there.
That's really interesting, Stu. So tell me, the Banana Pi. You obviously use it. You obviously like it. And why do you prefer that device over other alternatives? And I'm genuinely interested. That's why I'm asking.
I don't prefer it over any alternatives. There's a few things. As the packages in Slackware have got, well, let's name a few. So for example, Qt, Firefox, I think those are the two that come to mind as the biggest, fattest, hungriest for RAM packages that there are. And what happens is that you need machines that have more RAM, and you also need machines that are faster. So what I would do is, I had the ARM v5 Kirkwood systems. I have quite a few of them actually next to me in a box, switched off, because I've only got one left, which is the Slackware ARM 14.2 stable build machine. That's the only only ARM v5 thing I've got left in production, and the rest of them are actually in a box next to me in a cupboard. And so so I'd have this hardware, and then I take it, well, it isn't fast enough anymore. It's just slowing down development. It's taking too long. So let's just see what else is there. All right, there's a Banana Pi. Is it supported? Have other people got Fedora running on? Do they have Debian on it? Is it useful? Does it does it upstream? All those parameters I mentioned in the previous podcast. And that was what was available. It was affordable. It looked, you can put a case on it, because I'm not someone who wants like bare hardware lying on the desk. It's just a recipe for disaster. So it needs to have a case. So all these things, and that was what it was available. It had 1 gig of RAM. It was dual core, which was better than the Kirkwood, because that was only single core. And so really it was just a case of a moment in time. The Banana Pi came along. The test criteria passed, so I bought a few of them. I bought 2 of them, I think. So that I could upgrade my build machine and make it faster. And it just so happens that the Banana Pi is actually still, even maybe 2-3 years, if not more now, it's still working. I've got 3 of them, I think, and one of them is a servo. And it works fine. In fact, so it just so happens that it's a stable piece of hardware that works fine. I don't use them as a build machine anymore. I could do. When I upgraded to Linux 5.4 in Slackware ARM Current, I tested them all on the supported list of hardware, but the only build machines I use actively now are just 2 Orange Pis, because they've got 2 gig of RAM and they're quad core. So I thought about upgrading the Banana Pi into an Orange Pi, but then I thought there's no need. The actual server itself that I run my email on and run shell account on, stuff like that, 1 gigabyte of RAM is enough. It's sufficient. It's fast enough. It's not as fast as the Orange Pi, but it's fast enough for what it's doing. I don't care if it's slightly slower, because it's more than adequate. It does all of like the home gateway, all of the streaming, Netflix and all that stuff goes through it. Works perfectly. So I'm quite happy just to keep it as it is. It's a good piece of hardware. And then the Orange Pi is also perfectly fine. If I wanted one of those, I'd go and buy another one if I wanted to replace it. But yeah, I mean, to me, it's a case of picking out what's currently on the market that is sustainable in terms of I can keep supporting it. And it's got a future. It's got, if it hasn't got all the support currently, at least, I look at the All-Winner website, and go, the Linux All-Winner wiki, I think there is, and it says, okay, we're aiming, I don't know if you've seen it, but we've got in Linux 5 point whatever, we're aiming to get audio support. We're aiming to get, they've got a roadmap, is what I'm saying.
Yeah.
And so if I see there's a roadmap, there's a future, and currently use it, without, because these days I haven't got time to go and start getting loads of patches, assembling them, and I just don't have time. I need to go, okay, the base stuff is already in the kernel, I can take it and run with it. In the case of I would like a machine that now has more than 2 gig of RAM, because I spent absolutely ages getting things like Firefox working to build. Like, I was looking at Fedora, they couldn't even get Firefox to build anymore because they didn't have the RAM.
Right.
But because I can do things a little bit differently to what Fedora do, I can just do all sorts of crazy hacks to get stuff to build, and I have. So I've got Firefox building natively, but by switching out the GNU version of LD to the BFD version of LD, just because it's
more robust.
It's not that it's more robust, it's that the way it does linking, the algorithm, as far as I remember, I spent ages looking into this to find out why it wasn't working. And essentially, BFD version of the linker, which is called basically, if you look user bin ld.bfd. Sorry, hang on, am I thinking of BFD, or I can't remember now? I'll tell you what, I'm going to look. Let's see, Mozilla Firefox, because I can't even remember myself. It's one of these things that I get it working and then I just forget. But what I do is in my mind, I remember, I had a problem with RAM. Let me go back into the Firefox build script. How did I hack it? Oh, yeah, there we go. So, oh, no, I tell a lie. It is not the BFD version. It's the gold, ld.gold. So I've got some hacks in there to use the gold version of LD instead of the GNU version. Anyway, basically, the way they do the linking is built to be efficient. It was built to work with less RAM. Whereas the other version was presumably is maintained by people who've got absolutely loads of RAM on x86, 64 hardware. Because even on 32-bit, Firefox is difficult to build with 4 gig of RAM.
Right.
So on my 2 gigabytes of RAM Orange Pi, it was even more of a
challenge. Yeah.
A bit more of a challenge to get it working. But I have got it working. But I anticipate at some point it will break again. And I don't know what Qt5 is going to be like either. So that might be interesting. So at some point I might have to get maybe a 64-bit machine and run and use 4 gig of RAM in it instead, because I haven't found a 32-bit machine that has 4 gig. So this brings me on to something that's really important. If you're going to build packages for a particular baseline architecture, if we take, for example, what we call the software floating point of Slackware ARM, which is the final version is Slackware ARM 14.2. So the baseline of that hardware is ARM v5. So that's you can't really run it on any old ARM v4 hardware. It's built, for the base. It expects a bare minimum of the ARM v5 instruction set. The problem is that when you've got software that tries to be clever and tries to auto-detect everything, or does auto-detect things, what can happen is that, and this did happen in Slackware ARM 14.2, was that I changed the build machine from an ARM v5 Kirkwood into an ARM v7. I think it was a Banana Pi, because it was faster. Of course, I'm going to use the faster build machine, obviously. Yeah. The problem is with that, and Raspbian have this problem as well, everyone does, and so does Debian, as I'll tell you in a moment, is that the moment that you do that, you've got a potential problem because you're running a risk. So what happened was that somebody emailed me to say, I don't know which package it was now, but there was a particular package in 14.2 that just seg faulted. And so I was like, okay, it doesn't seg fault here. I got my ARM v5 machine out of the cupboard and plugged it in and went, oh yeah, it does seg fault, doesn't it? So, run GDB on it and found, okay, it's not the package, it's Mos.js, I think it's a JavaScript package library or something. So I was like, okay, it's seg faulting in that one. I think I know what it is. So I rebuilt the Mos.js package on an ARM v5 machine, and there it's fixed, because in the configure phase, it detected that it didn't have this instruction that's not an ARM v5. And so it didn't build a package that had some ARM. We talked about this on the previous podcast, I think.
Yeah.
For Guile, it didn't build binaries that included instructions that simply don't exist on ARM v5. So I was like, okay, now I've learned that lesson. My 14.2 build system is an ARM v5. It takes longer, but at least I know that what it produces works. But Raspbian have the same issue, and I think that's why they only build it on ARM v6 for the original Raspberry Pi. They built it on ARM v6 hardware because of that exact reason. You can go and, back in the day, there was something with RISC-PC where it was, well, it put it in a nutshell, the same kind of problem existed years ago in the RISC-PC. So I had some old code in the build scripts to detect whether it had built binaries that were going to fail. But I noticed the other day, because I haven't put any updates out for Slackware ARM for a few weeks now, for a few different reasons. One of them was Guile, so I still was hacking on Guile. And I came up to look at Debian and was like, Debian have got Guile 3 building. They must have a patch. There's no patch. Well, they've got loads of patches in there, but there's not one that fixes that. What are they doing with the compiler? No, there's nothing interesting in there. Absolutely nothing interesting at all. Nothing out of the ordinary. There's nothing at all that is going to make it build. So, how the hell are they building it then? And then I remembered. I think Debian, I haven't actually checked for Guile, but what they did is they upgraded some of their build systems, because Debian's built natively as well. They upgraded their build systems, I think, to be 64-bit ARM machines. And I think I'm guessing what's happened is that Guile is working on because Guile's one of these ones where it builds Guile and then it uses Guile to carry on with part of the build system. Right? So I think what's happening is it builds a binary that works fine on that hardware, and that's why it works. Whereas I don't want to cast aspersions on this. I'm thinking that if I took the package from Debian, the binary, and tried to run it in ARMSlack, it would fail. Is what I'm thinking. I haven't tested that, but that's what I think. Because it doesn't make any sense that it doesn't work for me and it doesn't work for other people, but it works on there. Yeah, you have to be really careful about that kind of stuff, which is also why I don't want to get a 64-bit machine just to get more RAM, because I think I'll end up producing broken packages. And I wouldn't know until it was too late. Actually, I was going to say, the other reason why there's been no updates recently is because there's been all these changes with Kerberos. And that's actually, even though I've automated a lot of the system and I don't have to do as much manual work anymore, when you've got changes like that, now Kerberos is embedded into Slackware, and you really can't separate it out. If you remove the Kerberos shared library, you'll find things fail. In ARMSlack, my build system, whenever I build a package, I don't like the package being on the system. I like to build from fresh. So in ARMSlack, what I do is the build scripts, mostly they remove the package if it's already installed prior to building it. The reason for that is because when I was first porting the ARM port, I wanted to make sure that the thing could be bootstrapped again, because you don't just bootstrap it once and it's done. You have to keep doing it a number of times to get the actual operating system all linked together. I wanted to make sure that these packages could build from the ground up without already being present on the file system. So in other words, like in a case of ncurses, sometimes there's like a circular dependency within a package. And so I wanted to try and find out what they were so I could script around them so I never had to go and manually do anything again. So my templates all just removed the package prior to building it. So I added Kerberos, and Kerberos built. And then on the second build pass, Kerberos gets removed and Kerberos gets built again. So Kerberos gets removed and then the build script kicks off and starts trying to compile stuff. And GCC just goes, no such file, link library is missing. So basically the entire build the rest of the passes just failed completely. Pretty much everything just exploded. And the build system started throwing a wobbler because the build script, because the system was going through, well, my build system, it doesn't quit when a package fails. It can do, but it doesn't, because that's, the whole point of my build system is that it does multiple passes so that I don't have to care if something failed the first or second time. So what happened was the build system goes along, it removes Kerberos, GCC is now failing. So pretty much all the other packages, so it goes, okay, that failed, never mind, next one on the list, let's go and let's remove that package and let's start building that package. So basically the system ends up with loads of packages that get removed, and so it kind of got itself into a bit of a state, which is one of the downsides of automating some of this stuff. So then I had to go in and start, okay, let's fix the automation. It's added, you have to maintain the automation a little bit as well, and so that's taken a while to get everything rebuilt to a point where I've soak tested the system and found everything is linked back together again and it's all happy. Yeah, you don't get to see any of those things. So I've left all of that, and then with the PAM stuff coming as well, if this breaks, I'm not in a position to fix this pretty quickly. So it's best not to put out a system that if I'm at all thinking it might break, I can't quickly fix it because I've got other projects and things going on at the moment. So conscious of that responsibility as well. So I haven't put anything out for a bit. In case anyone was wondering why, that's why. Let me check the status of it actually. Where are we now? Build pass 2 of 3, building Mozilla NSS. Everything is working. So that's so that's all good. So maybe I'll push some updates out this evening, get some of that stuff out there before PAM really takes really gets in there. I think everything seems to be good so far. I guess we should probably wrap up, shouldn't we? Yeah, I hope that people are finding this interesting, and what Phil and I what we're really aiming at here is both love working on Slackware ARM, I love the thought process that goes on behind it. The other day, oh God, I'm talking loads again now. We're supposed to finish. I was looking at, for example, FIFOs. I haven't worked with FIFOs since I was at university on a Perl programming project. I'd almost forgot what they were. Now I'm not a sysadmin. I haven't been working professionally with Linux in almost like 10 years or so. And then suddenly I was like, oh yeah. And you look at the Unix man pages and they're so well written. They explain how it works. Yeah, I love that kind of thing, and I think it's what we're really doing on this podcast is talking about something that we're both really passionate about. That's also really a technical project. And one of the things, I don't know about you, Phil, but for me, I'm not a master of Unix by any stretch. But that's what I love about it. The fact is, I will never know everything. It's never going to get to the point where I'll know everything, because first of all, there's so much anyway that it's impossible to know it all. But secondly, because it's evolving anyway. Yeah. So you'd never know it all, and that's what I find really interesting about it. And the more that you get into a distribution like Slackware, where you can actually, you've got a really nice framework and a set of tools to get going and to guide you and help you, you can go and easily start exploring. And I think that's one of the really great things that I really like about it.
Yeah, it gives you that freedom, and it's up to you where it takes you. The world's your oyster, as far as that's concerned, because you can just about do anything.
Indeed, with a bit of effort and some determination, and some going and reading the documents and thinking about it, and you can do it. And there's a good community around Slackware as well which you can tap into.
Thanks very much to Stuart for his valuable insight and time. We're going to wrap this podcast up now. Until the next time. Thanks very much for listening.
Cheers, guys.
Bye for now.